I'll be moderating this session today, and I'll keep everyone on mute while the presenters are talking. Today, I'm excited to share with you all the brains behind the Western Sydney University Solar Car team to have a Q&A session with all of you guys. Now, I'll get things started with some starter questions, but please, during this time, use the chat functionality to enter in your questions so the team members can answer them to the best of their abilities. To get started, could I please get each panelist to give an introduction of themselves, sharing their name, their position on the team, what they're studying, and a bit about what they like outside of Solar Car. If we can get started with, I would say Kartik.
Yeah, hi guys, I'm Kartik. I'm studying a Bachelor of Mechatronics and Robotics Engineering. On the team, I'm a mechanical lead, and something that I like doing in my own spare time. I'm really into making music and playing around with that sort of the side in the audio engineering world.
Hi, I'm Maggie. I am the comms lead for the team. I'm not currently studying anything. One of the things I like to do outside of Solar Car, I guess, is read books and like play video games, I guess.
Let's move on to you guys, Jonathan, Andrew, and Peter. Could you guys introduce yourselves?
G'day, I'm Jono. I'm the co-leader of the strategy team here at Western Sydney Solar Team. I'm studying a Bachelor Advanced ICT and Applied Data Science. Outside of Solar Car, I like taking pictures and playing games.
Hi, my name's Andrew. I'm the other strategy leader person. I'm studying a Bachelor of Computer Science Advanced, and I guess outside Solar Car, yeah, just sort of playing games other than just sort of spending time here. So yeah.
Hi, I'm Peter. I'm the electrical team contact at the Western Sydney Solar Team. I really enjoy electronics in general. They're my hobby both inside and outside of Solar Car, and yeah, I like working on my current spare time as well.
Awesome. Maybe Bernie, if you could introduce yourself.
Yeah, hi, I'm Bernie Fehon. I'm a strategy and, well, I am an advisor to the team. So I have studied mechanical engineering and industrial design, and I love car design, and it's fantastic just to be volunteering with the team and helping a whole bunch of young people get the job done.
Awesome. Lachlan?
Hey, I'm a mechatronics and robotics engineer at Western Sydney. Just finishing off my third year. It may have appeared like I've frozen. Is it all right?
It's fine now.
Okay, cool. Not sure how far that got through, but yeah, I work on the front suspension for the car, and in my spare time, I build and fly drones as well as ride mountain bikes and motorbikes.
Awesome. And last but not least, Griffin.
Hi everyone, I'm Griffin. I'm a fourth year industrial design student at Western Sydney. I'm a new member and I'm just part of the mechanical team. Myself, I enjoy basically anything nerdy from video games to tabletop RPGs, as well as making things on my 3D printer at home.
Awesome. Thank you so much. Let's get started with a couple of questions, and maybe I'll start with you, Kartik, on a bit of a broad one, but maybe a good one to start things off. Can you share a little bit about what the team have been up to in 2021?
Yeah, for sure. I'll actually take it back to where it started at 2020. June 2020, June, July, we were actually the Bridgestone World Solar Challenge for 2021, their regulations were released. So, from then on to, early this year, we've been quite, dedicated to designing and engineering our car that we would have raced this year. However, early 2021, we got the unfortunate news that the Bridgestone World Solar Challenge would have to be postponed to a later date, which we further then found out that it was cancelled for 2021. So, that left us with a lot of free time. What do we do now? We're a solar car team, but we can't build a solar car. So what do we do? So then, from there, we sort of, rethought, what shall we do? What are we capable of? And so, we decided we've come so far with designing a car. Why don't we manufacture it anyway? which will lead us to the decision of, let's keep engineering, keep designing to develop a scale model, a half scale model of the car that we would have been racing this year at the 2021 Bridge Solar Challenge. Along with all of that, we also decided to, we had a go-kart, just lying around, not getting used. So we thought, let's take it and let's make an electric go-kart. It sort of sits with our theme of electric cars being solar cars. And with that, we've continued on doing events. For example, the Bridgestone truck show that we did earlier in the year up in Brisbane. And even this virtual expo, it's one of our events, many events that we're still taking part in throughout, throughout 2021 and 2022 as well.
Awesome. Yeah, thank you for that update. I think that summarized a lot of what the team's been up to quite well. Let's go to one of our chat questions. Peter Callis asks, how was the driver of the solar car selected? And if I could direct this one at you, Andrew.
Yep. So driving a solar car, because solar cars are built to be very efficient vehicles, and getting the most out of that efficiency is the most important thing. So the thing that comes into driver selection, we will be looking at the weight of the driver. There's a minimum 80 kilogram weight requirement for both the Bridgestone World Solar Challenge and the Aussie Solar Challenge in the regulations. So the person who can be closest to that without being under, so they have ballast, and without being too much over, so it adds excess weight, is a large component, as well as the efficiency of that driver. A driver may not drive efficiently, so that sort of the people who can do that better is quite a large component as well.
Awesome, thanks. And let's keep it to that same camera as well. Jonathan, if I could ask you, Kartik briefly touched on the cancellation of the Bridgestone World Solar Challenge. Now this was, quite hard on the full solar racing community. How did the team cope with this?
Well, I mean, the team mainly coped with finding alternative projects to work on, as Kartik mainly covered. So yeah, as mentioned, the go-kart and the Expo and a few other things too. But something me and Andrew worked on during the COVID lockdown was a virtual racing challenge for the team, just as a bit of fun, because we'd sort of been working on a race simulator as part of our duties. So we had that to work with. And that was also a bit of setup for analyzing driver performance. So to expand on Andrew's answer in terms of how do we select a driver, well, we've built the tools that we can analyze their telemetry data and see how efficient they are in a very objective way.
Awesome. Yeah, no, that was quite a new thing for the team, and it's been quite fun to use that over the lockdown period. Speaking of continuing on the theme of lockdown, Bernie, if I could ask you, in a world of lockdown, it's so hard to genuinely connect with people. How has the team adjusted to keeping in contact with the industry and forming new partnerships?
Yeah, it's certainly been an obstacle, but I guess we all realise that so many businesses are continuing, and people are getting used to Zoom meetings and other online connections. So, from my point of view, as an example, I continued to do networking through LinkedIn. Even simple things like watching TV. If there's a relevant article on TV, I'll be reaching out to connect with the CEO or the chief marketing officer on LinkedIn, and some of that has worked really well. So an example of that has been the Tech Council of Australia, where that's exactly what happened. That was launched only in the last few months. There was a news article on it. I reached out to the CEO. She accepted my reaching out on LinkedIn, provided her email address. I was able to use some of the pitch documents that we would have normally done face-to-face and email those to her. She's delegated to her marketing manager, and the team got the opportunity to present, and we're now in discussions about doing some further work with them. And as we're witnessing here with this expo, there is an enormous amount that can be done online, and the world doesn't stop. And I guess take inspiration from the fact that there's businesses out there that are growing and thriving in this environment. So why can't this team do that as well? it's also being inspired by people like, Ben Felton, who many of us would have heard speak earlier today, who is unstoppable. And having that mindset to go, well, okay, now the rules have just changed. What can we do? It's not what we're missing out on, but more about what can we do given these constraints.
Great answer to that one. Thank you, Bernie. We have another question from Tim Curry. It asks, can you talk about a couple of lessons learned from the 2019 Solar Challenge? I think this question could be best answered by one of the few people who was, there at the 2019 race. If I could ask this to Peter.
Yeah, so there's been a few valuable lessons. One of the really important things is basically keep on top of everything. Any loose ends that aren't tied up can be basically very dire for a situation if they get out of control. Keeping on top of the loose ends also means that you're regularly reviewing parts of your designs and your systems and stuff, so you can spot potential future failures and stuff like that, and that helps with general reliability. So I think keeping on top of the loose ends, and I think
I'll just add a couple of things there, because this is really identifying the fact that there's a bunch of students, and it's a new bunch of students every time. And the fact that one race has been cancelled, it's a bloody disaster. It means that there's a whole bunch of people who miss out on that opportunity. And it really makes you value the practical experience that Peter has by he's one of the people that was there. And of course, Brad, who's the team manager, who's in another session at the moment with the school teachers, which is why he's not here in this group. But it also reinforces the real value that some of the team are getting currently hands-on. I know it's not solar car, but V8 supercars at the moment, some of the teams have been asked to volunteer there. They're getting some real hands-on experience about how do you fix carbon fiber bits when they break at the track. And why we've jumped at things like the Aussie Solar Challenge, and even in the absence of that, why we were organising a roadshow, and hopefully we'll still do one next year. The lessons when you actually do stuff physically are 10 times more significant than what you can do just by trying to rehearse it, theoretically.
Absolutely, and I think I speak for the whole team when I say we can't get back to actually running the car physically, and can't wait to compete in the Australian Solar Challenge. You mentioned a little bit about how the team constantly changing and evolving with new members. So we've got Griffin here. As a new member, could you share how you joined the team and how you found your experience so far in the team?
Yeah, sure. So originally I joined the team as part of a class to get industrial experience during COVID, and gain more experience working in a large team with a variety of backgrounds and skills, rather than the usual class-based group assignment where you all know the same skills, all have the same background essentially. And as I stepped in, I originally was really worried about joining as an industrial designer, stepping into a group that was traditionally filled with engineers. But as I stepped in, I was instantly welcomed, given a chance to use the skills I've developed over the past 4 years. The team are quick to teach and inform me about anything related to both the team, the cars, or anything involved. Even with my complete lack of knowledge about cars, they were happy to step up and explain things that should be obvious, but my experience just shows nothing about it. But the overall culture of the team is one of acceptance and learning that promotes basically learning at all levels, from the top to the bottom, and everyone has a voice, no matter whether you're new, old, or you've been there since it started.
Awesome. Thank you so much for that, Griffin. Let's move on to one of the more experienced mechanical members on our team right now, Lachlan. And now, as you mentioned, you're on the suspension team right now, and I'm guessing a lot of your work has been revolved around the scale model that Kartik talked about. So could you explain a bit more about what the purpose of the scale model is and how close is it going to be to a real car?
Yeah, look, so this is something I'm actually really excited about because despite Divyam mentioning that I'm one of the older members here, I haven't actually got to sit in a car and race it properly yet. So I joined a bit over a year now, and was in the heat of it before it got cancelled, and then afterwards we were all not at a loss, but looking for, hey, how do we keep on progressing? And this scale model is a perfect opportunity. So I know, as for me with suspension, this scale model has helped me keep on going with innovating and testing and making sure this will fit and adjustments. And up until, like every day we keep on working on it. So what's great about this scale model is it's going to use design techniques that we would be using on the real car. So making a mold, our carbon fiber layup. For me, we would probably be CNC machining suspension parts, but we're going to try 3D printing, metal 3D printing. It's going to be quite an exciting test, which may involve more CNCing. We'll see. But everything needs to work the way it would. So actuating suspension, different pieces. The car isn't one solid component of carbon fiber. There are different sections and different molds. We're going to be testing all of it, and it's a great opportunity to test theories, make sure that everything fits, works the way we need it to, and innovate. It's a great opportunity, and hopefully it'll be done in the next couple months.
Absolutely. Thanks so much for that, Lachlan. We have a question from Lisa over here, and she asks, a follow-up on the driver question. The car would handle differently to a real car. So how do you get used to driving it at speed? And what are some of the other challenges that the driver faces on the race course? Maybe I could direct that to one of you guys, Jono, Andrew, or Peter, whoever feels comfortable answering it.
Well, I don't think any of us have actually driven a solar car, but I think the key is definitely going to be practice. So before the COVID-19 lockdown in Sydney, we were planning on having several track nights at our partner Sydney Motorsport Park, where we would have given the drivers practical experience on how to drive a solar car in a track environment. But unfortunately, we missed out on those opportunities then, but I'm sure we'll be back at it soon.
Absolutely.
And just in addition to that, it's very different driving a solar car because efficiency is obviously key above all else, well, and safety. Yeah, so you need to have your drivers well practiced so they can drive efficiently.
Yeah, so just on that note, there's some pretty significant differences between a solar car and a normal road vehicle that are very significant when you're first driving. So your seating position is incredibly low compared to a standard passenger vehicle. So you're generally looking at like about the mid-door level of most cars. So that's great. You can see the same thing, but other people might not be able to see you as well. Your vision is pretty good in the forward direction, but not so great behind you. So you have to keep an eye out for obstacles in those kind of directions. And the vehicle is quite large in front of the driver compartment, whereas most cars generally have the driver fairly far forward. So there's some oddities going on with that as well. But yeah.
Awesome. Yeah, that makes sense. From all the stories I've heard about driving a solar car, I do not wish to be that person during the next race. It doesn't seem very comfortable. Michael J asks, for the scale model, how much are you manufacturing in-house versus using external suppliers? And I think that will tie very well into the Western Sydney University's advanced manufacturing precinct and some of the new unique machines that are in it. So Kartik, would you mind giving a bit of an answer with that one?
Yeah, for sure. For the scale model, our plan is to do 100% in-house. The university has got a facility called the Advanced Manufacturing Precinct, and that entails several 5-axis CNCs, a water jet cutter, a metal printer, the whole lot that you'd expect in a big machine shop. And the university is quite supportive of us as a team, and they want us to see us succeed, and we also want to support the use of the university as much as we can. And through that partnership, we'll work with the university to manufacture that scale model all throughout the advanced manufacturing precinct using those machines in there.
Awesome. Is there a favorite machine that you have by any chance? Something that I think not a lot of people would have heard of that you'd like to share?
Yeah, for me, it'd probably have to be the water jet cutter, to be honest. It's not something you see every day in a typical machine shop, but the capabilities it has, the power that it has, it's quite outstanding. It's the water jet cutter that we do have has the capability. It might cut off your hand if you're putting your hand in where you shouldn't be putting your hand in. But yeah, just the capabilities that it has, the power and the usefulness that it can have to cut certain materials a certain way, and the finishes that you're going to get out of those. Yeah.
Sounds good. That is quite a dangerous machine as I've observed from afar. For this question about tires, Peter, if I could go back to you, I think there's two questions that could be answered together. One is, can you go into detail about the type of tire used in the car? And also, what type of tire would you recommend for a high school team that's unable to obtain Bridgestone tires?
Yeah, so we use the Bridgestone specified solar car tires. They have a tire that's available to I think all or most solar car teams you can purchase the tires from Bridgestone. These are low rolling resistance tires specifically designed for this kind of application. Bridgestone uses them as a bit of a testing ground for their high efficiency tires. And so they kind of get that out of the race from all the teams who compete. So that's one of the reasons why they hold this event. Yeah, that's the same tire that we use. As far as what I would suggest to a high school team that are unable to get those, I would consider low rolling resistance moped tires that are designed for primarily city driving. They're about the same size and weight that you would want on a solar car. They generally handle all of the loads for the weight and the mass of a solar car and its dynamic loads. There's not much in the way of road vehicle tires that aren't for like mopeds that would be suitable, unfortunately. And then what was the other thing? Okay, yeah, that's pretty much it. Yeah. So.
Awesome. Thank you so much. We have a pretty great question from David Worsley. And so Lachlan, I know as part of the suspension team, you got to visit and work with Bilstein Suspension to sort of mentor the team a little bit on the suspension design. So if you could talk a little bit about how the industry resources are utilized as part of the design or manufacturing workflow.
I'm not gonna lie, this one's actually kind of confused me, but I actually wasn't there for the Bilstein one, very unfortunately. But look, we have our sponsors and we want to utilize them. So I know there's only so much I can research about suspension and get done. And I can happily design a suspension, but man, if I can utilize Bilstein's knowledge when it comes to suspension design and how their shock will actually interact with our suspension, I'm going to use it. It's like such an invaluable resource where I can just, instead of having to spend hours researching certain thing, I just be like, hey, do you reckon this is a good idea, or it would be better to go this way? And it's just so helpful having someone with that much knowledge being able to quickly just point you in a right direction. Saves a lot of time. And I've also noticed actually your telemetry, is that in terms of like FEA stuff, or am I misreading that?
I think telemetry might be referring to, the strategy system and the telemetry data from the car.
My job.
No.
Yeah, I might have to come back to that question. It's kind of stumped me a bit.
Yeah.
The first one.
No, that's all good. Maybe Jono and Andrew, since you guys are the strategy team, maybe you could talk a little bit about the telemetry question, and also about the industry resources question, because I know of the strong relationship that the strategy team has with industry partners like AWS and Solcast and so on.
Yeah, so I guess tackling the industry one is, we work with Amazon Web Services to sort of deliver what we're working on. They've provided guidance in a lot of areas that's been fairly critical to our operation and what we've been doing, and helped us along the way a fair bit, and they're very happy to support us with all our problems and such. And then there was, the role of and then for, I guess, more industry resources sort of relating to telemetry as well, is we have partnerships with Solcast and WeatherZone, who provide like industry standard solar forecasting and weather forecasting, which that then allows us to create a much better system overall, which then plays into, I guess, the role of telemetry.
Yeah, I can talk a bit about telemetry. So in testing, we need telemetry to validate the design of our cars, and we need to validate our strategy models. Because if our simulation of the car isn't at all accurate, well, then it's pretty useless. So we need to very carefully look at the telemetry data that we get during testing to validate our strategy systems, and also validate the design of the car that it is fit for purpose. And then during the race, we very much rely on telemetry data to make sure that we're following the strategy plan that we've set out. So we need to make sure that we're not consuming more power than we expected or anything like that, so that we don't like run out of power before the finish line. I think that covers that.
Awesome, it very much does. Thank you so much. Bernie, if I could look towards you for this question from Michael J, which asks, could you give an example of an issue that was identified with a previous race that we are trying to fix in this iteration? And I know 2019 was a troublesome race for the WSU team, not necessarily in a design term, but in a management sense as well. And I know there's been a lot of work in this cycle that you and Brad, our team manager, have put into fixing all of that. Would you be able to share a bit more?
Yeah, I'll share what I've pieced together, having been involved in the team since about January last year, which was well and truly after the 2019 event. But there was a technical and engineering issue there, and a design issue that I don't know whether everyone talks about it too much, but a gust of wind came, and I guess one of the points of failure was a catch on the array. So the array tilts up to allow access, and there was probably a lot of design work done to make the car as efficient as possible. And then, as you often hear in motor racing, a 20-cent part was what failed and cost the race. That was the lightest registered solar car ever, but it was probably, in retrospect, the design of that catch is something that could, if you had your time over again, you would have designed it differently. And it just reinforces the attention to detail that's required. So that's probably a lesson that everyone within the team who was there remembers, and hopefully everyone, by the telling of the story, realizes that attention to detail on even the smallest things is critical. The other thing that's really important, I guess, is about sustainability. This team is 10 years old. It's built, 4 cars or so in its time. It's building a 5th now. It's won the American Solar Challenge, which, to the Americans, they probably think that's the World Cup anyway, despite the fact that the World Solar Challenge is run in Australia. So, this team is capable of winning the best events in the world. So I think the lesson from the success in America is that it's a real possibility to win the World Solar Challenge. So that should maintain the focus. But the sustainability that I'm talking about is the sustainability of the team, that you can have a big finish and then fall in a heap, or you can have a big disaster and fall in a heap. Well, who's left to pick up the pieces? And there's some key people through that process that have been, part of that transition to lead to the team that exists now, including brand new members. But in 3 years' time, it'll probably be a different bunch of people. So the team needs to be constantly recruiting members and constantly recruiting sponsors, so that over the next 10 years, even greater things can be achieved.
Absolutely. Thank you so much, Bernie.
I was gonna kind of continue on from Bernie a little bit there. So Bernie mentions the sustainability for the team, but also in the way of sustainability for the car itself. Being able to repair and maintain a vehicle is not only really important for sustaining the vehicle throughout its lifespan, but it can save an incredibly large amount of time on a race. As Bernie said, in motorsport, often races are lost due to a 20-cent part failing. So if you can trade just the tiniest bit of efficiency for a huge amount of reliability, it's almost always going to be the choice to go for the reliability or maintenance approach. And that's a bit of a hard lesson.
And it's the Stephen Bradbury approach to winning the race as well. That he took his gold medal proudly based on all of the work that he'd done over a decade before, it's being there for the long term. The other thing that's probably consistent with that is all of the documentation that's now happening, the systems, the procedures, the software that's being embraced. COVID has probably even forced that even more, that in the absence of being in the workshop and being able to communicate with each other, everyone has to depend on the knowledge base, the database, the online chat systems, and all of that makes it more sustainable as well, so that new people can come in and get that corporate knowledge, as it's called out in the business world.
Thank you so much for that, Bernie and Peter. For my next question, I want to move over to Maggie with a bit of a different one. So, Bernie talked a lot about our win in 2018 at the American Solar Challenge, and I would say ever since then, this team has been always recognizable as the team from Western Sydney, and branding has played such a large part of that. As our communications lead, what is it about the team's image that is so distinct and so Australian?
Well, first I would just say probably consistent branding. We always have the crimson colored shirts and stuff, and the car as well. And I guess for the Aussiness, the team in general, we've just got a very laid back kind of chill culture, I guess, of the team, and we're always it's a stereotypical kind of Aussie personality, just very laid back and chill, and always willing to help and try and do our best or whatever. And also I guess probably as well, because we have a thing in the team, if someone says Aussie, 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 everyone has to yell oi, oi, oi. So it's just kind of the culture, I guess.
Absolutely. I'll quickly move on so that someone doesn't take it as an opportunity to get that chant going in here. Maybe I'll hand one over to Kartik regarding the Moroccan Solar Challenge. A lot of the solar car racing community has been following that event quite closely. Were you and was the team surprised by some of the cars that were being produced, and has our approach to the design for the 2023 race been influenced by that?
Yeah, it's definitely definitely a surprise, because the size of cars, it's definitely getting smaller and smaller, just like phones used to get smaller and smaller in your hands, or started small rather, going backwards in time, I'd say. But yeah, given what we've seen, given what we've heard from what's been going on over in Morocco, I think, it's definitely, playing around in our heads, what are we actually capable of? Seeing how those cars perform, seeing how what they're doing, I guess, on a race, going around different situations in a different climate. It's definitely something, to be considering in our heads. But we're true to ourselves, and we know, that we're going to engineer something good. So we're not going to be going off and copying somebody else per se, but it's definitely, putting ideas, I guess, in our heads of what's possible for us. What can we, really reach for? What can we, what should we be aiming for example?
Absolutely. Thank you so much, Kartik. We've got another question from Tim, and I might direct this towards you, Griffin, because I know you've been involved in some conversations with the UNSW team regarding some design issues. So Tim asks, do you do much design and research collaboration with other solar car teams?
Yeah, I'm not sure exactly how much is done, just due to the overall nature of the competition is quite secretive. So we can't go around discussing entire plans with other teams, because we may take their idea, they may take our idea, and in the end, it is still a competition. But there is a comradeship between the teams, as we are all just small university teams building a car from scratch, essentially. So there is information shared. One recently, me and Div were part of one we were recently part of was with a student who was doing his master's thesis on wheels, and we sat in, discussed, and listened to him talk about how carbon fiber wheels, his new designs that they were looking at, and how different composites could be achieved, and what their benefits, cons, and all the different things were used in the wheel. There was a good conversation. I'm afraid I missed most of it due to technical issues on my end, but it was very informative. We shared a lot of information back and forth, and through that, we were able to start thinking about how to develop the wheels in-house. So rather than just outsourcing them completely like we have in the past.
Thank you so much. And, I think that's definitely been benefited by the fact that, there's a camaraderie, like Griffin mentioned, especially between the Australian teams, because we want to get back to the top like we once were in the 90s. And we want to, stick it up to some of the big European teams who've been dominating the competition for so long. Now, also speaking about some of the Australian teams and the collaboration between them, the Australian Solar Challenge is a newly established event. So, Jonathan, could I ask you to share a little bit about that, and also how it's affected the strategy team?
Yeah, absolutely. So we did just touch on this briefly during our Understanding Race Strategy presentation previous to this. But I'll go over some of it again. The key difference is that the Aussie Solar Challenge is track-based, whereas the Bridgestone World Solar Challenge is road-based. And on the Bridgestone World Solar Challenge, you're basically just driving in a straight line for 3,000 kilometers, and it's relatively flat over that period. So from a strategy perspective, we can more or less think of it as a straight, flat line, and that greatly simplifies a lot of the calculations that you do. But when you're going around a track, well, you've got to slow down for corners, and then you've got to speed up on and out of those corners, and you're going over the same changes of elevation over and over again. So very different considerations from a strategy perspective, because now we need to try and figure out the most efficient way to handle slowing down for corners and speeding back up without going too fast around the corners, because that would be a big safety issue. And we also need to consider the mechanical differences, as solar cars are built for the Bridgestone World Solar Challenge are built to go in a straight line, suddenly requiring them to corner and accelerate very quickly over and over again does put different mechanical stresses on the cars than they're necessarily engineered for. So that's put some other considerations in for other sub-teams. I know Peter has been doing some electrical work to specifically optimize the car for track-based racing.
Awesome. Thank you so much for sharing that, Jonathan. And if anyone from the chat has more questions, please do feel free to continue typing them up. But the last one from my end is directed towards Griffin. Now, with the team being full of volunteer students, especially in a time like 2021 where there was no race, it's hard to see any, immediate rewards. What about Solar Car is it that makes it so attractive to young students and young professionals, and why should someone join?
Well, there's a lot of different aspects. The main one for me was the multidisciplinary aspect, where you're working with people outside of your area of expertise. So you're going to learn a lot more than you would in like generic teams with friends or in classrooms. As well as just there's no prerequisites for knowledge. It's very open, anyone can join, and you will learn something. Like even in your first few days working with these guys, you'll learn so much. The other thing is the openness and the freedom of the idea of developing a solar car. It's not like joining other mechanical teams where you've got a set thing and it's like we're building a Ford. Everyone knows Fords. There's thousands of them. With the solar car, there's only one solar car for your team. And for the one that we're working on, like there's only one TED 2. Nowhere else in the world is there another TED 2. And that's very freeing, having the set restrictions for the solar car, but then other than those restrictions, doing anything you want, any shape, any number of wheels, and just finding ways around conventional issues with a creative team, and then putting that into practice and seeing that then race, essentially. It's very open, very freeing, and it's something that you don't get in a lot of groups, whether it's through university or just generic external hobby-based groups. And the fact that it's not only freeing, it is also professional. You get a sense of everything. It's everything wrapped into one. It's casual enough that you don't feel like you have to show up in a suit and a tie. But it's also professional enough that you feel like there's deadlines. You have a purpose, you have a goal, you have a direction, rather than showing up, seeing what happens and hoping for the best. There's direction without restriction. And as well, like you get to see what your work can do on a race. And you don't get to see that a lot in hobbyist groups as well. And it's once a year almost, rather than professional projects, which could take 3, 4, maybe even 10 years. There's like a car a year, and it's a wild experience, I'll say. And it's very appealing to just anyone who's even just generally creative, because there's a team for everyone.
Awesome. Yeah, no, great words, Griffin. Thank you so much. We've got one more from David Worsley, which I think is a very, very great question. And if you wouldn't mind, Brad, I know you recently joined, but I'd love to pass this one to you. And he asks, what is the approach to quality assurance and management to help translate design concepts into results?
Yeah, so I think that's a great question. And I would say two things, validation and numbers. So just to sort of walk you through what I mean, once we've got race regulations in our hands, we extract rules and add in, our own sort of rules into a document, which is design requirements for parts and for subsystems, and then the overall vehicle. So then, that helps us transition into the next phase of design, which is CAD modeling. And once we've created our concepts on CAD, then, we'll move into the stage of validation and optimizing through computational methods. So we'll use FEA, finite element analysis, and CFD, computational fluid dynamics, to then again, work with numbers and have that numerical system of validating, our designs. And that sort of philosophy and method is reflected through the entire process. So, when we're doing our physical work and our composite layup, we've got temperature controlled or a temperature controlled room that we operate in. We're in big sort of hazmat looking suits to ensure that no contaminants get between layers of, composites. So yeah, I think to answer the question in short, numbers are everything in terms of, you know, quality assurance and translating that into concepts which become a reality.
Sorry, I was on mute. Thank you very much, Brad. And I think that was a great little answer to end this session on. So once again, thank you all so much for joining. Thank you to all the panelists for being here to answer the questions, and a big thank you for everyone who submitted their questions. And I really hope that people got some answers and some insider knowledge from the team that they were looking for. Awesome. So this session will once again be available to view after the expo, and I hope to see more of you guys for our sessions tomorrow to continue the expo. Thank you so much.